To pick up where the introductory video left off, a summary of absolute value equations and inequalities for a positive number a. So if the absolute value of x is equal to a positive number, then x is either equal to the opposite of that positive number or x is equal to that positive number. If the absolute value of x is less than a positive number, then x falls between that number and its opposite. If the absolute value of x is greater than a positive number, then x is either less than the opposite of that number, or x is greater than that number. If the absolute value of an expression is compared to 0 or a negative number, we're going to stop and think this is a special case. So in example 3, the absolute value of 2m minus 3 divided by 4 plus 9 is greater than 5. I'm going to start by undoing that plus 9 because we want to undo the operations in reverse order. So if we subtract 9, 5 minus 9 is negative 4. This gives us an absolute value that's compared to a negative number. So I'm going to think about this. An absolute value is greater than negative 4. An absolute value generally yields a positive number, except for when it yields 0. Now, a positive number is greater than negative 4. 0 is also greater than negative 4. So this statement will always be true for all real numbers. So all real numbers are solutions of this inequality. In B, we have to subtract 8 from both sides of this inequality. 2 minus 8 is negative 6. I'm also going to stop and think. Here we have an absolute value that is less than or equal to negative 6. Well, an absolute value can either be positive or it can be 0. A positive number less than or equal to negative 6, that will never be true. 0 less than or equal to negative 6, that will never be true. So this inequality has no solution. So as you can see, just because we get a negative number on one side doesn't mean that there's no solution necessarily. We have to stop and think about whether we're looking at a greater than or less than type of a situation. Okay, in C, we're going to think of this as 6 plus negative 2 times x minus 3 divided by 5 less than or equal to 4. This will help us remember what operation to do first. We're going to subtract 6 from both sides. And so if we subtract 6, 4 minus 6 is negative 2. Next step, we have to undo that negative 2 and think about what the negative 2 is doing to the absolute value. It's multiplying it. So in order to undo it, we're going to divide it out. So negative 2 divided by negative 2 is positive 1. But remember, we divided by a negative number. So that's going to switch the direction of the inequality to greater than or equal to. And when an absolute value is greater than a positive number, then the inside of the absolute value is either less than, or in this case, or equal to the opposite, or the inside is greater than or equal to that number. I'm going to multiply both sides of inequalities by 5 and then add 3. And let's do the other side of the or. Multiply by 5 and add 3. And our solution to this inequality is an or statement. That's a disjoint set. The only way to say that is or. Either the x values are on the left side of negative 2 or they're on the right side of positive 8. In D, we have an absolute value plus 3 less than or equal to 3. So we're going to start by isolating that absolute value by subtracting 3 from both sides, and that'll give us 0 on the right-hand side. So let's stop and think, because this is not a positive number. So an absolute value is less than or equal to 0. Well, an absolute value is a positive number or 0, so it cannot be less than 0, but it can be equal to 0. And so an absolute value is equal to 0 when the inside of the absolute value is equal to 0. And if we subtract 6 and then divide by 2, that'll give us c is equal to -3. So this inequality has an equation as its answer. C is only equal to -3, as opposed to a group of numbers, those greater than or less than a certain number. Okay, in this last example, we're going to isolate this inequality here by adding 3 to, or isolate the absolute value by adding 3 to both sides. And so this is an absolute value of an expression is greater than or equal to a positive number. That happens whenever the inside is either less than or equal to its opposite, or when the inside is greater than or equal to that number. Let's multiply both sides by 2 and subtract 1. And then do the same thing for the statement on the other side of the or. We're going to first multiply by 2 and then subtract 1. And we get an or statement as a result. Okay, it's your turn. You're going to try matching each of these absolute value inequalities with their solution graphs. Now, when you do so, try to think about plugging in numbers and just see what numbers work. Experiment around a little bit with it, and then pause the video and we'll check the results. Alright, here are the results of the try these. And lastly, we're going to try these inequalities down below. So let's try A first. Pause the video while you try A. Alright, this one's a little bit tricky. We have to think about an absolute value being greater than 0. Well, absolute values generally yield a positive number, which is greater than 0, except for when they yield 0. So the only time when this inequality won't be true is when the absolute value is equal to 0, and that's when the inside of the absolute value is equal to 0. So it's only not true when x is 1. So our solution here should be actually x is not equal to 1. Alright, your turn now to try B. For this one we have to stop and think again. An absolute value less than a negative number, that would be a positive number, or 0 less than a negative number. Neither one of those things will ever be true, so this has no solution. Alright, your turn to try C. Pause the video while you try this one. Here's the solution to C. The absolute value of a number less than a positive number. That means that the inside of the absolute value has to be between that number and its opposite. Alright, last one to try on your own here is D. Pause the video while you try this one. This inequality yields an absolute value greater than a negative number. And since an absolute value gives you a positive or 0 result, positive numbers or 0 will always be greater than -6, so this is true for all real numbers.